we now go into a shape. Let's give you a shape. Let's take a cylinder, right? And I tell you that this here is x, and I tell you that the height is 300 minus x. I tell you that question number 1. Now generally this is the style in which your questions are going to be asked under calculus. This is the last part. It's worth 10 marks in your exam. So after you've done first principles, after you've done derivative, after you've done limit, after you've done finding the equation of a tangent at a point, after you've done the cubic function, now we get to optimization. So now the questions, they give you a shape and they say, show that the volume of the shape of the object is given by volume is equal to 942x squared minus 3,14x cubed. They're going to give you a hectic formula on that side. Okay, that's the first one. Show that the volume of that shape is given by that. Question number 2 in here, and that will be for about 3 or 4 marks. Let's call it 3 marks. Question number 2. Find x giving maximum or minimum volume. That will be another 4 marks. And the last one, find the maximum volume of the object. And that's another 3 marks. 4 and 3, 7, and 3 on the dot, 10 marks. Okay? Now, generally this is the style in which the questions will ask. Show that the area, show that the volume, show that the total surface area is given by a formula you've never seen before. Then they say find x giving maximum or minimum, and then find the maximum or minimum volume or area or total surface area. Now when we do this, I want you to pay attention. When we do question number 1, we use standard formula. Standard, let's write it, standard formula. When they say minimum or maximum, we know in calculus, whenever they talk about minimum or they talk about maximum, what are they talking about, guys? They're talking about derivative. That's where we're going to be using derivative. Find the maximum volume, that's where we're going to substitute. And this is the order, this is the style. That's how simple it is. Standard formula, derivative, and find the maximum volume. So let's answer the question. What do we know? Question number 1. Show that the volume is, what do we know about, forget about that. What do we know about the volume of a cylinder? Volume is equal to pi r squared times height. Yes or no? What is pi? We're going to be using pi as 3,14. What is r? R is x squared. What is your height? 300 minus x. Are there brackets here? No. Should we remove the brackets? Yes. So this is 3,14 times x squared is 3,14 x squared into 300 minus x. Now we multiply this 2 out. The volume is equal to 3,14 times 300 is 942 x squared minus 3,14 x squared times x is 3,14 x cubed. And there we go. We've showed that the volume is given by that expression for that specific shape. Okay? We found the volume. We now say find x giving minimum or maximum. What did I say? Minimum or maximum, what do we use? Derivative. So to answer question number 2, we take volume. Volume is equal to 942 x squared minus 3,14 x cubed. We're now going to be using derivative. So we're going to say dv over dx. We're finding the derivative in terms of x. Therefore dv over dx. Now we're going to be using power rule. So don't ask me what I'm doing. We're using the power rule. Power times coefficient minus 1 from power. Power times coefficient minus 1 from power. So 2 times 942, 1884. 1884 x minus 3 times 3,14 is 9,42 x squared. What do we know for minimum or maximum? It's always equal to 0. Now we've got 2 values there equal to 0. It's quadratic. We now need to solve for x. So take out your highest common factor. What's your highest common factor here? 9,42. I'm taking out HCF. I'm taking out the highest common factor. I've got 2 terms equal to 0. So 942 x is my highest common factor. Now how do I find my other 2 factors? I take each term and I divide it by what I took out. So 1884 divided by 9,42 will give me 200 minus 9,42 x squared divided by 9,42 x will give me x. So I've got 2 factors equal to 0. I got 9,42 x equal to 0, or I got 200 minus x equal to 0. So now x is equal to 0. 0 divided by that is 0. Or negative x will equal to negative 200. X is equal to 200. Okay. Now in this case, x, we know x can't equal to 0. Therefore, 200 is x giving maximum. In this case, therefore, 200 is x giving maximum volume. Now, I need you to pay attention. Sometimes you will get this here as say 100 and that as 200. Let's say you get 100 and 200. Can we automatically assume that 200 is x giving maximum volume? That the higher x is really the x giving maximum volume? You'll have to check. You'll have to take each one of them, substitute it in the original. Because sometimes if I took 200 and I plugged it into here, I would get a negative volume. Can you ever have a negative volume of a shape? No. So therefore, the lower x, in those cases, in certain cases, your lower x will be x giving maximum volume. Why? Because it's giving you a positive volume. So you'll have to just do it by check. Trial and error in the exam. Take your lower one, plug it in, get a value. Take your higher one, plug it in, get a value. Check whichever one gives you your higher positive value. Remember, the higher positive value, the higher positive x value gets maximum. Higher positive x value gets your maximum. Now they say question number 3. So what did we do? We got question number 1. We did the derivative. We solved for x. Now they say find the maximum volume of the shape. So obviously we now found x. So the next most obvious thing to do is to plug that x back into original. So v is equal to 942x squared minus 3,14x cubed. So volume is equal to 942 into 200 squared minus 3,14 into 200 cubed. Your answer to this, I think it's 1256000 units cubed. That's your final answer. So you take your final answer, you plug it in, and that would give you your final result. Boys and girls, we're taking an ad break. When we get back, we're going to continue with optimization.